vectors. So in order to be able to put vectors together, you don't just add them together. Okay, you don't just add them together. Like if you have a vector of magnitude 5 and of magnitude 7, okay, the result does not have a magnitude of 12. You can't just add their magnitudes together. You have to break them down into their components and combine their components. Okay, so this example, though, already has it in component form. We want to find the magnitude and direction of the resultant of each pair of vectors. So we're going to put these two vectors together and then find out what their result has as magnitude and direction. Okay, so we are putting together a vector in the fourth quadrant and a vector in the second quadrant. Right, this one's in the fourth and this one's in the second. Okay, based on positive and negative x and y values. Okay, that really has no bearing on the problem at this moment, but I just wanted to point that out. All right, so we can add the x components together and we add the y components together. So the resultant in component form is -9, -6. So what quadrant are we in? Third quadrant. Okay, so we combined something in the fourth and the second and we ended up in the third. We could have just as easily ended up in the first or in one of those other two quadrants. Okay. Okay, so we've got it in component form. It wants the magnitude and direction, though. So we need to square the two pieces and add them together. So 9 squared is 81, 6 squared is 36. So that gives us the square root of 117 for the magnitude. And for our angle, theta is the inverse tangent of y over x. So that gives us 33.69 degrees. Does that make sense? No, we're in the wrong quadrant again. So we go back and add that to 180. So we get, what, 213. Okay, that is the correct direction angle for this resulting vector when we combine those two. Okay, let's do another one just to make sure we got it. We've got -15 and -1. That is in the third quadrant. And +12, +16, that's in the first quadrant. So let's see where we end up. -15 plus 12, -1 plus 16. So that puts us at -3, -15. We are still in the third quadrant. No, +15, +15. Why didn't y'all catch that? Whew, +15. Second quadrant. I was like, that doesn't make any sense. Start at -1, add 16, and end up with -15. Not quite. +15. All right, second quadrant. So our magnitude, 9 plus is 15 squared, 225. Yeah. Okay. So that's the square root of 234 for our magnitude. Our angle is the inverse tangent of the y, 15 over the x, -3. Okay, notice what it gives us, -78.69 degrees. That's an angle in the fourth quadrant. We use it as a reference angle again in the second quadrant this time. So what is our actual, how would we find our actual angle there? 180 minus, or guess what? You can just do add 180. And we get 101.31 degrees for the correct direction angle.
So is that all you always have to average that 180?
In this case, we've added 180 both times.
Yeah, but that way.
Well, yes. I mean, it's always going to be in reference to 180. Yes, because if it's in the first or the fourth, it's going to be correct. Yes, ma'am. Okay.